Okay, so let's move on to the final section of the challenge problem for chapter 22. And so this problem is A, B, C, D, E went shopping. So we have the five people, A, B, C, D, E, and each of them has the whole number, right? They have the positive integer number of dollars to spend, and together they have the 56. A plus B plus C plus D plus E is equal to 56, and now we know the absolute value between of them. Okay, so A and B is equal to 19, then B minus C is 7, then C minus D is 5, and D minus E is 4, and E minus A is 11. Okay, so the question is, what is E? Okay, so this is the logic problem is because we have the A minus B is 19, so we have many possibilities, right? So you have two possibilities here, two here, two here, two here, and two here, right? But the cycle is constant, right? So you have 32 possibilities. How we can significantly reduce all these possibilities, okay, is the thing. So for this type of thing, we're always starting from the biggest range, okay? So the largest range maybe give you the end, and we can try to complete all the points in the middle. So let's see the A minus B equals 19. The second one is E minus A equals 11, okay? So without loss of generality, okay, just let's assume just A less than B in this case, okay? So that means the A and B is 19, right? Okay, so there are two ways to define the E, right? So the E could be here. So this is 11, right? Or the E could be in the middle, like here. So the E can be here, right? So this is the A, B, E, and this is the 11, this is the 8, right? Okay, so now let's see, okay? If E is here, right? So we can see the B to C, C to D, then D to E, right? So you can see the E to D is somewhere 4, right? So let's assume we need to approach from B to E, right? So B to C is 7, right? Then C to D is 5, right? So you can see here is 12 and the total length is 19, right? So that means after 12 it is still 7, right? So D to E is definitely greater than 4. Okay, so this is not the case. Now we have this case, right? Now we can see B and C, right? So we can see if B is C is going to this direction to the 7, then we go back to the best case is go back to 9, right? So that's here. This side is 2. So this is the D. No, I mean, if this is 7, then we go back to 5. It's here, right? So the D and the E is definitely greater than 8. So it's not a way, right? So the only way we can do it is C is B need to go back to here, to the C. Then this is 7, right? So this is the 1. This is the 7, right? And the D need to go to the B to C. Then D need to go to another 5, right? So because D to E is 4, so you can see we must go in this way. So this is the D, this is the 5, right? So this is the 4, so this makes it 5. Okay, so now we find the one possibility layout. That's very important. Let's draw it here. So we can see it's the A and the B, then and if this is a 4, this is a 7, right? So D, this is 7, then to the E, this is 4, that's 11, right? And now E to the C is 1, then C to the B is 7. Okay, so total is 15. Okay, then you can see AE is 11 and this is 8. Okay, so this is the one case, and we have the second possibility is the B and A, right? So the A to the E is 11, right? And B to the C is 7. B to the C is 7, so this is the E, so 7 and 1, right? And the C to the D is 5. C to the D is 5, means this is 4, right? And A to the E is 11, so this is 7. Okay, now let's list the results for these two cases. Okay. Okay, so let's list the A. Okay, so the A is assumed to be X. Then the B is here is X plus 19. The C will be the X plus the 12. The D is the X plus 7. The E will be the X plus 11. Okay, for this one is B is the X. A is X plus 19. Okay, then C will be X plus 7. Then D will be X plus 12. And E will be X plus 8. Okay, now let's solve it. So this is the 5X plus this is 31, right? Plus 31 plus the 18. This one is 5X plus 49 equals the 56. So you can see here X is not an integer, right? Does not belong to integer. So this case is not the case. And let's say this case is 5X plus the 20 plus the 26 equal to 5x plus the 46 equal to 56, right? So now we can say x equals 2. If x equals 2, now we solve the E is x plus 8 is 10. Okay. So next. So we know the number can be written as this format. Okay, let's see. So now we can square this number, right? Plus the b root 3 plus the c root 5 of the square is equal to, expand this, is a is the a squared times 2 plus b squared times 3 plus c squared times 5. Then we can plus the 2ab root 6 plus the 2ac root 10 plus 2bc root 15. Okay, then we can compare this format, right? So we know that 2ab is equal to 104, and 2ac is equal to 468, and 2bc is equal to 144. Okay, so now we have the AB equals the 52, then AC equals the 234, and the BC is equal to the 72. Okay, now if this is the case, now let's see. So solving this part is simple, right? So we can do the a square, b square, c square, right? Is equal to the 52 times 234 times 72. Then we can have the a times b times c will be equal to the root of the 52 is 52 times the 117 times the 144, right? So we can get this one equals 13 times the 72. Okay, now once we solve the ABC, right? 2, 3, and the ABC should be greater than 0, right? Because a greater than 0, b greater than 0, c greater than 0. So negative doesn't work. So that's why we can using the ABC divided by AB here, right, is c equal this, so we get c equals 18, and same reason we get a equals 13 and b equals 4. Okay, since we solve the ABC, okay, we only using this part. We only using the square root part. Now we need to final validate this part as well, okay? So now let's see. This part is the 2a squared plus the 3b squared plus 5c squared is equal to the 2 times the 13 squared plus 3 times the 4 square plus 5 times the 18 square is equal to 2 times 169 plus 3 times 16 plus 5 times the 3, 24. So final you will check it is 2006. So that's it. Okay, so the final question is if we know this, what is this? Okay, so let's assume a is equal to the 1 over 1 square plus 1 over 3 square plus what? Okay, now let's say b is equal to 1 over 2 square plus 1 over 4 square plus 1 over 6 square plus. Now we can see, let's take out 2 square, so it becomes 1 over 1 square plus 1 over 2 square plus 1 over 3 square plus forever, right? If this is the pi square over 6, so this is 1/4 times the pi square over 6. Okay, and we also know the a plus b equal to the a plus the 1/4 of pi square over 6 is also equal to pi square over 6. So now we have a equal to 3/4 of pi square over 6. So this one makes a pi square over 8. Okay, so yeah, that's it for the challenge problem of this chapter, also the challenge problem for this whole book. Thank you. Bye bye.